This call is now being recorded.
Cool. So before starting this last lecture of rotational mechanics, I want to discuss first syllabus. See, what have been completed, what is yet to be completed. Okay. First, let's get the clear idea about that. So I'm going to read the topics, and you will confirm that we have done that topic in our class. Is that fine? This is the NEET syllabus. Yeah, and please try to open your mic and then do a conversation here, at least at this part. So, have we done center of mass of a center of mass basically?
Yes, ma'am.
Cool. And okay. So, basic concepts of rotational motion, where I gave you the idea of analogy between linear and rotational variables. What is torque, moment of inertia, kind of cheese? Have we done that?
Yes, ma'am.
Cool. ठीक है. So I think moment of force, torque, angular momentum, we have done all of that.
Yes, ma'am.
Okay. Conservation of angular momentum and its application. Basically, I guess last lecture is on the PYQ session, which is based on angular momentum only, right?
Yes, ma'am.
Cool. Now let's come to the second para, and it says the moment of inertia, the radius of the gyration, values of moment of inertia for simple geometrical body. You remember that table which I gave you?
Yes, ma'am.
For 5 bodies, rings. Yeah, okay. So we have done this much. Okay, extra apne aap ho ja raha hai. We have we done the theorems? Perpendicular parallel axis theorem.
Yes,
Yes,
ma'am.
ma'am.
Cool. Equilibrium of rigid bodies. That static equilibrium.
Yes, ma'am.
Okay. Then we have done the rotational equations. See, you remember that those equations like V is equals to U plus AT. So in angular terms, we can write it as omega final is equals to omega initial plus alpha T. Yeah.
Yes.
So we have done that. Cool. And the last topic is comparison of linear and rotational motions. Again, that simple analogy, which is the basics also. है ना?
Yes, ma'am.
Yes, ma'am.
Cool. So basically, as per the syllabus of NEET, we have completed this unit. Okay, unit completed hai, and this is your syllabus for your upcoming test. Okay, which will be held on 4th of Feb. Most probably you will get the notice, via photo or something, but you will have the information. For time being, I'm telling you, I'm discussing the syllabus for physics. Okay, we are going to take the test for rotational motion. So please make sure that you've covered all the topics, whether it is theoretical or numerical. Okay. Now, since today is our last section of rotational mechanics, हाँ, बोलिए, कुछ कहना चाह रहे हो?
No, ma'am.
Okay. So basically, as I said, we have completed the entire chapter, all the topics. Now it's time to do its PYQ session. And it would be your second session, because in the first session, in the first PYQ session, we have completed the angular momentum only. I think in 2 or 3 slides, I give you the idea of angular momentum, and in the remaining time, we have done the numericals of last 35 years. I told you that. I think I remember it. Okay. So this is the second session of PYQ, and obviously it concludes the entire topics, all the questions and everything. Okay. So today is 30th of Jan, and okay, let's begin with our lecture. So in the starting, can you give me the ideas of few things? I mean, if any one of you want to, give a recap of entire chapter of rotational mechanics. Anyone? Just tell me in your words what we have done till this point of time. Hmm? बताओ.
Types of motion.
मिसबा एक बार फिर से बोलो.
Types of motion.
Okay, good. Types of motion, बिल्कुल. That's how we started this chapter. And
Stress and strain.
क्या बेटा एक बार फिर से बोलो.
Ma'am, stress and strain.
Stress and strain? I don't think so. We have covered that topic in this chapter.
Moment of
Right?
analogy.
Okay, आपकी आवाज ही मुझे क्लियर नहीं आ रही. आपको मेरी आवाज क्लियर आ रही है?
Yes, ma'am.
Yes, ma'am.
ओके, ठीक है. एक बार फिर से बोलो, थोड़ा आराम से बोलो. क्या बोल रहे हो? टाइप्स ऑफ मोशन के पाथ. मोमेंट ऑफ इनर्शिया. गुड. एंड सबसे इंपॉर्टेंट तो वो एनालॉजीज हैं, राइट?
Yes, ma'am.
थोड़ा थोड़ा मैं इनके बारे में आपको याद दिला देती हूँ फटाफट से. टाइप्स ऑफ मोशन, हमने 3 टाइप के मोशन पढ़े थे. फर्स्ट इज ट्रांसलेटरी मोशन, द अदर वन इज रोटेशनल मोशन, अदर वन इज प्लेनर मोशन. ट्रांसलेटरी मोशन इज फर्दर ऑफ 2 टाइप्स, रेक्टिलिनियर ट्रांसलेशन मोशन एंड curvilinear translation motion, right? I told you one specific thing about rotational motion that you should remember, that it is the collection of
Circular motion.
Circular motion.
circular motion, right? Exactly. Then analogy, remember the one thing that displacement is angular, the replica of angular moment, displacement. This is the linear velocity, this would be angular velocity, this is your A, it would be your alpha, this is, force over here, and it would be your torque. Then we have mass, moment of inertia. Then we have linear momentum and then angular momentum. This much we have, right? Okay. Besides it, we have done a table of moment of inertia for geometrical bodies, and for further any other journal axis of rotation, we can have theorems. So basically, how many theorems we have discussed?
2 types.
Two theorem.
Okay. Parallel and perpendicular. Parallel theorem का statement बताओगे? What is the statement for parallel
2D
theorem?
lamella.
No, it's parallel. For parallel 3D body, right? And one in axis of rotation must pass through, yes, center of mass. Yes. Here, that laminar structure, X, Y, Z are supposed to be perpendicular to each other, and IZ should not lie in the plane of the body. IX and IY, basically X axis and Y axis should be in the plane of the body. I should draw a body and I will write this is X, this is Y. The Z should be like this. Basically, this looks like a Z and let's make it Y. Okay? That's how we design these theorems. Okay. इसके अलावा the most important thing which I realize is equation of motion, equations, right? Equation of rotational motion. Yes. What are those 3 equations? Batao? Gayatri, can you help me with these equations? Gayatri, are you there in the class?
Yes, ma'am.
Okay. So give me the 3 equation of rotational motion basically.
Torque is equal to mr2s.
What? No, those basic equations when alpha is constant. Well, you have studied about equation of motion in linear terms, na? For constant acceleration. I'm asking you to give me the three equations for rotational motion as well, where alpha is constant. Yeah. Gayatri, इसका मतलब revision नहीं चल रहा है, you're not revising properly, right? Please do not do that. Make sure that you revise every lecture, every class.
Sorry, ma'am.
Theta is equals to, no, that's fine. But make sure that you revise every lecture. That is important. Sorry, it's V is equals to U plus AT. So it means omega final is equals to omega initial plus alpha T. The other one is S is equals to UT plus half AT square. So it will become theta omega initial T plus half alpha T square, right? And the other one that we have is V square, which means this, U square, which means this, and 2 alpha theta, right? So these are the a very quick recap of all of this chapter. Okay. Now let's start with the questions. These are your PYQs. Okay. It is from 2022 and the question goes like this. Two objects of mass 10 kg and 20 kg respectively are connected to the two ends of a rigid rod of length 10 meter with negligible mass. They gave you this condition that rod has negligible mass. The distance of the center of mass of the system from the 10 kg mass would be. Okay? So basically you will have 1 minute to solve this question. It's 18:04 right now. Kindly give me the answers on the poll. Okay? Within a minute, I'm going to launch a poll. See, poll is live with you. Kindly answer over there. Okay, so I've got only 3 votes. Now I have to, switch off this poll. Let's go with the solution. Yeah. Okay, I think I got 1 more vote. Yeah. Cool. Just give me a second. You can still cast your vote, so please do that if you want. Okay. Okay, so yes, I've got 5 votes. That's very cool. I'm showing you the result and let's go with the solution. Okay. So in this question, if you go through this question, very deliberately, so you will get the idea that we have 2 masses where M1 is 10 kg and M2 is 20 kg. Okay? They are asking you to find the coordinate here, find the distance of center of mass from 10 kg. So whenever you don't have a particular origin or a coordinate system in a question, so always consider that mass at origin, with respect to which you are going to calculate the distance. So I guess here it would be 10 kg mass. So put your 10 kg mass at origin. Okay? And from it, let's go with the length of the rod, which is 10 meter away. So it would be like this, and here you will get the another mass 20 kg, right? So if this point is at origin, then this point eventually would be at n comma 0, right? Since there is
Yes,
no
ma'am.
contribution to the second dimension, yes, so we're not going to take its coordinate. It would be 0 in y direction. Now, what we have? Nothing. Okay, just calculate the coordinate. I guess you remember that formula which I gave you while discussing that system of particles wala portion. So I gave you one thing, that x center of mass would be m1 x1 m2 x2 divided by m1 plus m2. Yes or no?
Yes, ma'am.
Huh?
Yes, ma'am.
Exactly. Okay. So m1 would be your 10 kg, x1 would be 0, m2 would be 20 kg, and x2 would be 10. Just add two masses and solve this question. So it would be 20 into 10, 200 by 30. 1 0 will get cancelled out, and you will be left with 20 by 3 meter from 10 kg. Just for instance, if you have that, calculate the center of mass, the distance of center of mass from 20 kg. So I guess you now get the idea ki how do we gonna solve that, right? How do we gonna solve that? We put 20 kg first, mark it as origin, and then we will do the calculation. Is that fine? So let's
Yes,
mark the
ma'am.
correct option. Exactly, it would be 20 by 3 meter. Let's come to the next question. It is from 2020, and the question goes like this. Two particles of mass 5 kg and 10 kg respectively are attached to the two ends of a rigid rod of length 1 meter with negligible mass. The center of mass of the system from the 5 kg particle is nearly at a distance of. So you're getting the idea by yourself that this kind of question on basically this pattern has repeated twice within 2020, first in 2020, then 2022. Okay, so it's a nice question, easiest I would say from this chapter. So make sure you will do this question this time. I want at least 10 votes right now for this question. Okay, I think let's do what? Let's end the poll. Just give me a minute. Okay. I guess there is some issue with my network. Yeah. Wait a second. Mm-hmm. Just 1 second, report. Okay, I'm trying to fix it. Yeah. So I'm basically ending the poll with 6 votes only. As I said, this is not acceptable, bhai. I told you ki at least do 10 votes. You're 16 people over here. And I just explained you ki how to deal with this question, how to solve this question. I mean, am I asking too much? Huh?
No, ma'am. No, ma'am.
हाँ तो exactly. I mean, ठीक है चलो. Two particles of mass 5 kg and 10 kg respectively are attached. Okay. In this question, they are asking to find the center of the distance of center of mass from 5 kg, from mass 5 kg, right? 5 kg वाले mass से वो निकालने बोल रहा है, तो it would be 0,0. You will consider that entire rod here, and the another mass would be 10 kg. Okay, put 10 kg over here. ठीक? They said it is 1 meter long. I think in the options you are getting centimeter. So it would be nice if you consider this distance as 100, comma 0, right? Now just calculate the formula exactly was is calculated. So x center of mass would become m1 x1, m2 x2, m1 plus m2. I guess it would become 5 within bracket 0, 10,
100.
2, 3. क्या बेटा? 6 centimeter, if I'm not wrong, which is near to
Yes, ma'am.
67 centimeter. As
Option,
question is
option
also
C.
asking ki nearly, so it would be 67 centimeter, right? Your option C would be your answer. Very good. Hanji beta. Let's come to this question, which is again asked in 2022. ठीक है, in thin uniform disk about an axis passing through its center, पहली चीज, and normal to its plane to the radius. Okay, wait a second. And normal to its plane to the radius of gyration of the disk about its diameter. Okay, we have to find two inertias here and then do the ratio. So it is your third question. Right now, the time is 18:15. You will have 2 minutes to solve this question. Okay? I'm going to launch a poll. Kindly answer over there. I'm ending the poll. Let's go with the solution. Yeah. एक minute. Okay. So I've got 6 votes for this question as well. And the maximum vote goes for option B. So I really want it would be option B. Let's do the question. Okay, so thin uniform disk. What is the moment of inertia when it is passing through the center of the disk? When the axis of rotation is
Half
passing through the
mr
center.
square.
Huh?
Half mr square.
Exactly. About its diameter,
1/4 mr square.
about its diameter, it is 1/4 now. Exactly.
Yes, ma'am.
So what we do, we kept inertia as mk square. Okay? So from here, you can have k is under root I by m. Since m is same, because the body is same, so we can say that in this question, the radius of gyration is directly proportional to under root of I. So if I want the ratio of these two things, what it would be actually? It would be I1 by I2 now. So you can put the value
Yes,
of
ma'am.
I1 as mr square by 2 and I2 mr square by 4. Right?
Yes, ma'am.
And it is your option B indeed. Very nice. Harshita, do you want to ask something?
Yes, ma'am.
To ask something?
Ma'am, actually, there why you took mk square for the inertia formula?
Come again. I think today I have some network issue because Jennifer, yes, you can do text little bit. I will understand it. Yeah, I'll explain this question. See, we had talking about the inertia about two axes of rotations for the same disk. If I'm talking, if I'm seeing be seen, it's just that since we are changing the axis of rotation, we will have two different inertias over here. So when axis of rotation is passing through the center of disk, then it would be half mr square. When it is passing along the diameter or through the diameter, it would be 1/4 mr square. I gave you this data in that table where I gave you the inertia of 5 balls. Huh? Anyone?
Ma'am, you are
Am
not
I
audible
audible?
clearly. Ma'am, your voice is breaking.
I'm not audible. Okay, let me do few changes. Okay. Am I audible now?
Yes, ma'am. Yes, ma'am.
बेटा just wait a second, I'm trying to fix my screen. ठीक है, I'll come back. बेटा screen visible है? Is the screen visible to you?
Yes, ma'am.
Okay.
Yes, ma'am.
Am I audible properly?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. ठीक है. हाँ जी, अब बताओ. So I'm saying कि here we have two different axes of rotation about the same disk. One is at center of mass, and other one is passing through the diameter. Is that fine?
Yes.
Okay.
Yes, ma'am.
Okay.
Ma'am, we have to find the ratio of both the inertia rate, so we can directly calculate by under root y or took I is equals to mk square.
Oh, wait a second. Let's go to the question again, and then we will discuss about it. They are not talking you to find out the inertia, the ratio of the inertia. It is the ratio of the radius of gyration. Now, they want you to calculate K1 by K2. Do you know what is radius of gyration? Huh? देखो,
No, ma'am.
this one is now an imaginary concept. We consider that at this point of radial distance, let's say K, at this point of radial distance, the inertia would be equal to the actual moment of inertia of that body. You know, whatever the mass distribution that is actually there in a body, let's say they all have together the inertia I. So this, if you cap the m mass at k radius, you will get the same inertia. This is you would say an imaginary concept. Okay? This is how it is defined. I is equals to m by k, mk square. Is that fine?
Yes, ma'am.
Okay, that's why I use this formula and I substitute k is equals to root I by m, and like this, k is directly proportional to the root of I, and that's how I solve the question. Is that fine?
Yes, ma'am.
Okay. Let's do one more question on radius of gyration. Okay, it will give you a nice dealing of this concept. In 2021, we have another question from this chapter, and it goes like this: from a circular disk of, basically it's called from a circular of mass m, radius r, and r corresponding to a 90-degree sector is removed. The moment of inertia of the remaining part of the ring about an axis passing through the center of the ring perpendicular to the plane of the ring is k. Times of this. Okay, it is not related to radius of gyration. This is another question. You have to find the value of k. Okay, I thought I added that
Yes,
question.
ma'am.
Let's see if in the for the few questions. So this is your question number 4th, I guess, right? Yes. This is your question number 4th. Right now the time is 18:28. You have 2 minutes to solve this question, and let's answer over the poll. Okay. So I'm ending the poll right now. I've got 5 votes only. Let's go with the solution. It says we have a circle of a mass m and radius r. 90-degree sector is removed. So firstly, you need to calculate the mass of removed portion, or you need to basically calculate the mass of remaining portion. Basically, we have a circle, right? As per the question, we have a circle over here. Let me draw a nice one. Yeah. Okay. So we have this circle, and what we did, we removed a sector of angle 90-degree, right? That it subtends 90-degree at the center of this ring. So I guess you get the idea that we have removed the 1/4 portion of this disc, or sorry, this ring, whatever we have this structure here, right? Basically, we remove this portion,
Yes,
ना,
ma'am.
जिसको भी मैं solid line से कर रही हूँ. इतना portion. Since here we have the uniform mass distribution, so if you remove the 1/4 portion, so the mass of remaining portion would be m minus m by 4.
3 by
It
4.
would be 3m by 4. Exactly. And if I want to find the inertia, it is mr square. Now I want to find the inertia remaining portion, so I need to put the mass remaining, and it would become 3m by 4 r square. Now they say compare this thing with the k times of mr square. So if I'm comparing it with k by mr square, I think you got the idea. That next thing is we're going to compare them, and we can write k is equals to 3 by 4. It is your option B. Right? It is your option B. Yes or no?
Yes, ma'am.
Yes, ma'am.
Cool. Let's come to the question 5th. Question 5th is from 2015, and it says that an automobile moves on a road with a speed of 54 km per hour. The radius of its wheel is 0.45 meter, and the moment of inertia of the wheel about its axis of rotation is this much. If the vehicle is brought to rest in 15 seconds, the magnitude of average torque transmitted by its spring. Okay, we need to calculate the average torque, as simple as that. Right now, it's 18:34. You have again 2 minutes to solve this question. Kindly answer over the poll only. Okay, Mispa. The question goes like this: an automobile moves a road with the speed of this. Okay? So we have basically a vehicle which is moving with this much speed. The radius of its wheel, obviously a vehicle, it moves on the wheel. So basically they gave you the radius of wheel and the moment of inertia of wheel about the axis of rotation, and that inertia is 3 kg per meter, 3 kg meter square. They said we applied the brake, okay? And on the
Yes,
result of
ma'am.
this, vehicle is going to stop. You need to calculate the torque. Okay, so I'm ending the poll. Result is live with you. All 5 votes goes to option C. And yes, it is the correct one. Very nice. This is the correct option. See, in this question, the V that we have is 54 kilometer per hour, which can be written as converted into meter per second. So it would be 15 meter per second, right? They gave you the radius
Yes,
of the wheel as 0.45 meter. The inertia that we have is 3, okay, in SI units. Now they said the vehicle is brought to rest. If it is coming to the rest, then the final angular velocity is going to be 0. And they said in 15 seconds you brought the vehicle to the rest. So basically, they're asking you to find the torque. We know that torque is I alpha. So I is pretty much sorted. We have the value. But we need to calculate alpha. So that's fine. Alpha would be omega final minus omega initial upon t. So final is 0. But we need to calculate the omega initial. Right? We need to calculate the omega initial. And for that, we have V, we have R. I guess you remember that formula that V is equals to R omega. So from here you can calculate the omega, which would be 15 by 0.45. So let's solve it. It is meter now. Yeah. So 15, 1 and 15, 3, sir. Right? Put it here. You will get 100 by 3 multiplied by T is 15 second. Right? T is 15 second. And just calculate the torque. So torque would be inertia is 3, alpha is 100 by 3 into 15. We will cancel out 3 by 3 and we are left with 100 by 15. It would be 20, it would be 3, and yes, it would be 6.66 kilogram meter square radian per second, or you can say R cross F के हिसाब से it is Newton per meter, right? 66.66.
yes, sir.
That one is correct. Let's come to this question, your 6th question. A nice question, actually. It is about static equilibrium. The question goes like this: a uniform rod of length 200 centimeter and mass 500 gram is balanced. Okay? Mass is 500 gram. On a wedge placed at 40 centimeter mark, a mass of 2 kg is suspended from the rod at 20 centimeter. And another mass. You have this question, just go through this question and answer me. Right now it is 1840. You will have 3 minutes to solve this question. Okay? And the next one would be your homework. This is the last question of today's session. I'm going to launch a poll. Kindly answer over there. Okay, so let's start with the solution. I'm adding the rule over here. I've got only 4 votes. Statistics is not good, huh? Chali, let me draw this diagram, or okay, I'll explain it over here. So basically, you will say कि ma'am 0 centimeter is at this point, at this end, ठीक at end A. The end B is at 200 centimeter, or is at 200 centimeter. This 2 kg is hanged at 20 centimeter from A. The wedge is at 40 centimeter from A. The mass M is at 160 centimeter from A. So basically, the origin is A. The standard point is A. Okay? We need to calculate this mass M. That is your question. So what I'm going to do, I will calculate all the forces, all the possible torque for this wedge. Right? And the reason
Yes,
being,
ma'am.
yes, the reason is we know this is 20. We know this would be mg. But what about the normal reaction over here? So we will consider it as A. The normal reaction, but not A, the normal reaction at the wedge. Okay? Okay. Wait a second, I think my screen got stuck. All possible technical glitches are going to come in today's session. Yeah, हट जाओ. Yeah. So let's say if this is normal reaction at wedge. I already told you that whenever we got 2 surfaces into contact with each other, there would be a contact force, which is the normal reaction. So what we will going to do that this 20 kg, yani ki this much force is at 20 centimeter distance. Yes or no? This the distance between point A and wedge is 40 centimeter. Distance between point A and 2 kg is 20 centimeter. So the distance between 2 kg and the wedge is going to be 20 now.
Yes, ma'am.
Bolo? Okay. Similarly, am I visible? Okay.
Yes, ma'am.
Yes, ma'am.
Similarly, this okay. Similarly, this mg force, right? This mg is at what distance from the wedge? Can you tell me the distance between wedge and the point mass m? What is the distance in between wedge and this mass m? बताओ. बोलो बेटा.
120 centimeter.
Exactly. So mg and the distance is c. This entire distance is 160 centimeter. This much distance is 40 centimeter. So the remaining one is 120 centimeter. Right? Just put the values and solve the question. 400 divided by 10 multiplied by 120 is equals to m. 2 zeros will get cancelled out and it would become 1 by 3 kg. And this is your answer. So what we did, we put the torque about wedge is 0. Is that fine? Right?
Yes, ma'am.
Yes, ma'am.
Okay. Okay. Take this question in the homework. Okay, I'll upload the PDF, otherwise took the screenshot. Then this question is your homework as well. They're simple questions, right? You have to do cross product and all, and you will get the answer. And similarly, this one also. Have you take the screenshots?
Yes, ma'am.
Okay. So in next class, we will do what we will do. Okay, I'll tell you in the group. Okay, I'll tell you that in the group. Yeah. For time being, I will share this PDF as well. Thank you so much for being so nice. Okay, have a nice time ahead.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Welcome.
Thank you, ma'am.
Welcome, bacha.